Welcome back to Building a Private Cloud with Windows Server 2012 and System Center 2012 SP1 Jumpstart. I'm Simon Perryman, Technical Evangelist with Microsoft, and I'm joined again by Pete Zerger, a MVP with System Center and a consultant. Now, as part of our first module, we kind of spent some time covering some of the design and planning considerations as far as moving to the private cloud. We looked about key questions that you want to ask your customer to figure out what's the best model for them. What type of infrastructure design do we want? What type of service design do we want? Now, as part of this module, we're going to kind of move forward a little bit and spend some more time really looking at that fabric, that infrastructure layer. So, Pete, let me turn it back over to you, and why don't you go into a little more detail on this module?
Happy to, thanks, Simon. So we're going to spend some time really looking at the cloud fabric now and taking those requirements we gathered in our initial Q&A with our cloud tenants, our stakeholders, our sponsors, and map those requirements into features and capabilities we need to build into our fabric. So we're going to talk about really the core tenets of the fabric. We're going to talk about storage and network and compute, and which of those features in terms of high availability, in high performance and throughput are really going to make sense, and where they make sense. So it's not so much telling you, that Hyper-V over SMB is really cool and gives us high throughput, but when and where does that actually make sense? If I'm going to look at high throughput storage capabilities, where I need to put those into my environment. Our fundamental design principle is always as simple as possible, as complex as necessary. So I'm only going to step across that line into high availability and fault tolerance and high scale where it makes sense for me. So I want to use my resources as efficiently as I can. So if I have those bronze level non-critical resources, I'm going to minimize my use of expensive infrastructure for inexpensive or low priority services.
Great. And I think it's important to remind our audience that we are going to a level 300 here. We are going to make some assumptions, go into some pretty reasonable technical depth. So if there's some additional background information that you're looking for, feel free to ask our live Q&A team, or go back to TechNet or the Microsoft Virtual Academy to learn more.
Yeah, great point. And we're really covering a lot of technology in the span of a day. So level 300 can seem like a pretty quick pace. And frankly, if I were to go off and to really try to wrap my arms around this technology in my own pace to really learn it end to end, I might be working for a few days or a few weeks to really get the practice I need. So don't really take today as the full measure of where you'll be. This is really just where you're getting started. So I think what you're going to have in terms of an advantage here is you're going to know all of the things not to do and all of the things that you should be doing that 2 or 3 years ago were a mystery to me. So we'll just call that accelerated progress. So with Server 2012, I want to start with the storage layer. With Server 2012, there's a lot of new tech in the storage layer that's very exciting in terms of scale. So we saw with our virtual machine scale settings within that slide back in Module 1 that we can now scale much higher within a virtual machine. When we look at workloads like SQL, for example, one of the core tenets of virtualizing SQL is we don't virtualize a workload that requires more vCPUs than we can put in a VM. So back in Server 2008, that was 4, right? So it was, I believe so, fairly small, so it was very limiting. So now we've got a lot of capability within a virtual machine to host a very large, high-scale, high-performance workload. So we need to make sure that we deploy storage capabilities in the back end to match what we have in the front end in terms of service delivery.
And we're now up to 64 virtual CPUs in Windows Server 2012.
A ridiculous number of CPUs.
1 terabyte of memory, wow.
I don't know. So suffice it to say that's going to handle most of even our high availability workloads, or our high scale workloads rather. So we're going to have a look at some of these high performance capabilities in the storage tier. We'll look at scale out file servers and what we can do to provide not only high availability, but to simplify administration in the storage tier, to allow non-SAN gurus to administer storage in some respects. We'll look at that SMB3 feature we talked about that gives us multi-channel capability. Most importantly, though, we're going to look at it. We're going to have a picture when we step out of this module of how we can leverage these features together and how their interdependence is going to really give us a solution. We're not thinking about features anymore. I'm now thinking about that end-to-end picture of my storage infrastructure and how I can use these these new features in Server 2012 in concert to deliver a greater capability in my cloud fabric.
Now, a question for you, putting on your consultant hat here. Between the storage spaces, SMB3, scale-out file server, which do you use the most, or do you generally use all of them at once?
So the answer is it depends. So when we look at SMB3, we mentioned earlier that SMB3 is just there by default, right? I don't have to do anything. So if I have a pair of NICs that are running at the same speed, if receive side scaling is enabled, which it's going to be in all of our newer hardware, SMB3 just works. So that capability comes out of the box. When we look at scale-out file server, when we look at storage spaces, these, I almost call these evolutionary technologies, because today everyone works in the world of SAN with virtualization hosts connected to the SAN. And storage spaces and scale-out file servers really remove those constraints. They take away the shackles and give us the capability to develop SAN-like capabilities with an interface that's vastly simplified and very flexible. But not everybody's ready for those, so it comes to that point of opportunistic deployment, perhaps.
Now, I mean, would you see this change being along the line of how we virtualized our servers, we virtualized our networks, now we're trying to virtualize our storage?
That's exactly what it is. And when I first saw this in Server 2012, it was a surprising direction to me, frankly, but it works, and that's really what counts. So with storage spaces, I can take much less expensive storage and develop that high performance, high availability, SAN-like capability for my workloads that maybe don't require that top-end fiber channel SAN with really expensive switches. So I can go out and buy just a rack of just a tray of JBOD, just a bunch of disks, and with storage spaces I can begin to build those arrays in the software now. So really software-defined storage to create an inappropriate and unofficial acronym. So storage spaces allows us though to take just a bunch of disks and to pool those together and to configure availability as to how we like. So I can stripe storage disks in a storage spaces pool. I can set up a mirror. I can add parity, which might, in layman's term, take us back to RAID. So we know that RAID 1 is a mirror, right? We know that RAID 5 or RAID 10 is going to give us some element of parity there. I'm going to have a parity stripe. So just as in RAID 5, for example, I have to have 3 or more disks with that parity feature in storage pooling, I would have to specify 3 or more disks. It's fundamentally very similar, parallel in many respects. But what's great about storage spaces, from my perspective, is that we can also thin provision in storage spaces. So if somebody asks me, if a business unit comes and says, I need a terabyte of storage, but I only have 100 gigs right now, I can thin provision a terabyte and just know that I need to backfill to add that extra storage as as they consume. So, which is where my holistic strategy of actually monitoring my cloud to make sure that I'm watching my capacity, watching my utilization, so I get that heads up that hey, you thin provisioned this, we're running out of capacity, so give us some more storage over here where we thin provisioned.
Now, I've already got a few questions coming in. Will storage spaces work with insert vendor name here? Dell, HP, Fujitsu, etc.
Yes. The simple answer is yes, right?
Yes. Any disk, in theory, we can go add this management layer on top of it and just manage it, regardless of who the underlying hardware provider is.
So it's limited to SAS, SAN, SSD. Insert vendor name here. It's really quite flexible. We're sort of abstracting these odd bits of storage that we're bringing together in a pool to deliver that capability of SAN-like functionality.
And I think, taking that concept a step further of being able to pool these different vendors, that simplifies our automation, our scripting, because we have the ability to script and communicate with our storage spaces APIs. Under the cover, that will then translate that to Dell language, to HP language, to EMC language. So essentially, you're simplifying your management here using a single management interface, regardless of this underlying hardware.
Yeah, that's exactly right. And we also want to think about the quality of storage we're putting behind there. So it doesn't eliminate, it simplifies, it doesn't eliminate that reality that some storage is, not all storage is equal. Some is expensive, some is less expensive. We still want to think about those resource pools, those classes of service. So just as I was thinking about pools of Hyper-V and VMware hosts based on availability, capacity requirements, etc., I'm going to have that same sort of logical consideration for the storage tier as well.
Great.
So, that being said, storage spaces is kind of an evolutionary technology. What I find in the field, frankly, is that not everybody is ready for that. So we look at this as an opportunistic deployment when we hit a hardware refresh cycle. Maybe I buy servers and I buy a tray of Fujitsu JBOD, 24 disks, and I use that at a much less expensive price point. I don't have to, pay for my SAN tools. That's something when we think about the expense of storage. It's not just, these arrays of disks and the expensive fiber channel switches. We also have fairly expensive management software in many cases that we have to purchase to fully manage these. And I've been in that situation, just as we talked about with System Center licensing in the old days where we couldn't do something because we didn't own a license. I've been in that situation on the SAN side where the folks say, well, we can't do that because we didn't license snapshots. And I'm thinking, really? I own this very expensive tier and can't fully use it. So that is challenging for sure. So let's think about that storage space's capability in the context of SMB 3.0. So I have network adapters, fairly new hardware. I can get 10 gig E now in Blades standard. I load Server 2012 on there in SMB 3, and that multi-channel capability just works. I can interface with storage spaces and potentially drive high throughput to high performance storage that's abstracted back there.
Now, I'm going to jump back for just 1 second
Okay.
here and just kind of quickly talk about SMB3 itself. So SMB is a protocol which we basically use to go communicate over our networks. So it stands for the Server Message Block and is primarily developed by Microsoft. And so with this release, Windows Server 2012, we kind of upgraded from version 2.0 over to 3.0, but it is still an industry standard protocol. So don't think that you're kind of restricted as far as who can use it. Though Microsoft developed it, it is public, it does have open APIs, so anyone can go plug in and go use this new protocol.
So since you raised the topic of open and not open, what about NFS support?
I'm going to let you take that one.
Yeah, so NFS support is there. So if we need to provide storage for VMware or non-Windows systems, we can do that. So it's not an all or nothing situation with SMB3. We've got NFS.
Great point. You're not
NFS
bound to just using that. You have some flexibility.
So again, thumbs up Microsoft marketing. They said cloud on our terms, and so I'm kind of a nerd in that I take all of these Microsoft marketing messages. Which
you remember them? Good for you. I like that.
I remember every bit of them, but I take them and I apply technology to them. So cloud on your terms, in my view, means that if I need to manage and deploy in a heterogeneous enterprise, that I can do that. My favorite private cloud project was actually System Center 2012 Service Pack 1, deploying 100% to the VMware hypervisor. 50-50 Windows VM guest, and the other 50 were Linux and Unix. So very exciting capabilities. And we were able to design it, deploy it, test it, and see people actually getting real benefit from that in a very large and distributed enterprise. So it's not just about the Microsoft workloads for sure. And to speak to cross-platform briefly, this is an area where 3 or 4 years ago I would see, when I mentioned Microsoft monitoring or managing Linux, I would see eyebrows kind of raised. And this is not an isolated effort in a dark room. So I first saw Microsoft supporting cross-platform in a meaningful way in 2007 when I was working with Operations Manager monitoring cross-platform workloads. We now see that branching out into multi-generational support on the hypervisor. We now have cross-platform Linux and Unix agents for Configuration Manager, which are shockingly Windows-like in how they present Linux and Unix assets in the Config Manager console. So this effort by Microsoft is really multi-generational in terms of product now and really spanning across the System Center product into the various components and back into the hypervisor. So we're just getting more and more capability from Microsoft to manage our existing investments and not being forced into multiple point solutions for managing the enterprise. So from an architect perspective, I'm always looking for that opportunity to manage as much of my enterprise in a single tool set to minimize the need for learning and switching between consoles and developing multiple automation strategies. So really minimizing the switching on the KVM switch, so to speak, having to go from tool to tool. So SMB, I think we've covered that off nicely. Suffice it to say, SMB, I'm not sure if we mentioned this already, allows us to deploy virtual machines into SMB shares, which means I can deploy a Hyper-V virtual machine into a folder. Incidentally, we can also do that with SQL 2012 databases now, so it's not just a Hyper-V phenomenon. But it really doesn't end there. So with that SMB3, with Hyper-V over SMB3 in Virtual Machine Manager, I can also add my scale-out file server, so my file server cluster, which is highly available, potentially deploying to storage spaces. So look at that diagram there. I have a Hyper-V cluster using SMB3, potentially deploying virtual machines into folders, which are highly available folders, sitting on SAN-like storage that may be a SAN or it may be storage spaces. So I'm beginning to layer these features into a solution that's going to be performant, but simpler than it might be if I look at the technologies we're accustomed to from the past.
Right. I just want to emphasize one point. I've had a couple questions come in here asking whether storage spaces supports clustering, supports cluster shared volumes, things like that. Absolutely it does. So no worries there. Clustering you really want to consider is kind of the infrastructure, the key pieces that interconnect your different servers. So as we kind of want to encourage people to use network virtualization, storage virtualization, we do want to ensure that our infrastructure supports that. So good news, full support.
Yeah, and that's a really important consideration. These new features would be much less exciting if they painted us into a corner.
Standalone host on this one, right?
Yeah, absolutely. If we were painted into a corner from a service level capability perspective and not able to deliver the level of service we needed because we'd implemented some new feature would really be a big negative. So good to hear that. Let's talk about data deduplication for a minute. I hear a lot of confusion around data dedupe in the field, and really the question is, when is data dedupe appropriate, really, is the only word I can think of. Should I use data deduplication with virtual machines? Should I use data dedupe with my libraries? At the end of the day, we do want to be careful with data deduplication on a live virtual machine, right? There's going to be, when we have a lot of bits changing, our ability to reclaim space is going to be somewhat limited. So am I going to turn data deduplication on for a big virtual SQL server? Probably
not ideal.
Yeah, but when I'm looking at my library, my VMM library, by the way, where I have lots of ISOs that are sitting there doing nothing, massive savings, 80%.
Yep. And I see VDI being one of the most popular scenarios as well, right? You have all of these client virtual machines that are used by the help desk. 90% of the binary, that information on the VHD file is identical. Great way to really consolidate and really be able to scale up your VDI infrastructure as well.
Yeah, and that's a battle a lot of times you can choose over in a test or a staging environment, so you can see what your reclamation is going to be. You really want to make sure you can justify where you're going to see the big savings. I don't want to necessarily deploy dedupe where I'm getting 5% savings. I want to find those 60, 70, 80% use cases and optimize. So SMB Direct. I want to just touch on a couple of the high performance features that we see out there. Let's say you've got a client and a server and you want to request data, maybe 500K of a client. That's typically going to go through the IP stack, right? It's you place the request to the server, the data gets read, gets broken down into packets, gets transferred over to you. You assimilate all these packets back, and all this takes CPU, and you can't send the entire 500K at once, down to no matter how fast your NIC is maybe. So you have to chop it into small packets. So if I'm pushing 500 gig all at the same time, I'm going to be looking when I'm pushing lots of data to find a way to offload to some device further down the stack. So that's where something like SMB Direct is going to give me that capability of leveraging the features in my new network adapters that come in modern hardware. So you know, with the NICs that are out there today, with remote direct memory access, RDMA, we're going to be able to offload a lot of that high throughput data transfer without taxing the CPU in the guest, right? So I'm pushing the processing down the stack to specialized hardware where it makes sense. So why is this important? If I want to virtualize those tier 1 workloads, SharePoint, SQL, Exchange, this is going to give me the capability to push a lot of data very fast in a virtual world. So we can, you know, step forward with a lot of confidence that we can virtualize these high scale, you know, high availability workloads in a reliable way, and in a way that's going to perform on par with what we would see in the physical world. Most customers I work with see that as a reality today. I do walk in, and I would say where 2 years ago 80% of my customers would say, I'm not virtualizing SQL, forget it. Now I would say, you know, that's 3/4 have moved to the side of virtualizing SQL, at least in modest to moderate workloads. Maybe not that, you know, mammoth mission critical, you know, data mart, but many workloads beneath that for sure. And with Server 2012, with some of these, you know, high performance storage capabilities and network capabilities, we now have the opportunity to rethink some of those past decisions and maybe take another step into increasing our virtualization footprint.
Yeah, that's a great point. You know, I often get asked by all these customers, you know, what other real-world customers have actually done this, have moved to these highly virtualized environments, have moved to virtualizing SQL. So a great resource for our customers out there is going to the website aka.ms/evidence. What that's going to do is actually take you to our case studies website. From the website, you can actually filter by looking at different companies in your own geography, your own type of business. And then different case studies, people that have gone to these highly virtualized world from physical servers, migrated from a VMware infrastructure to a Microsoft. So again, aka.ms/evidence. Go check out those case studies to see how our real-world customers have actually been successful doing that.
And that's so important when you get out of bed one day and think you must be the only person in the world, you know, the only organization in the world trying to do this. Trust us, you're not. You know, a lot of people have taken their lumps for you and learned over time, and so you can capitalize on those capabilities. So let's have a look at another high performance feature. Let's talk about offloaded data transfer. So if we have ODX capable servers in the form of Windows Server 2012, we have an ODX aware SAN. We can move lots of data by really not necessarily moving data at all.
It's almost redirecting pointers, right?
Really, that's exactly what's going on. So at the end of the day, server A sends a little token that in the end tells server B, you know, and the SAN here is where the storage needs to point to now. So I can take a massive database, virtual machine, insert whatever it is down there you're moving, and really it's a pointer changing hands through this token that flows, rather than
copying between us, using a server as an intermediary.
Yeah, exactly. We're not even pushing a bunch of data through high performance network adapters at this point. We're really just changing the pointer, so it's much more exciting.
So what type of scenarios could a customer actually use to take advantage of ODX? When are these, you know, big storage efficiency benefits happening?
You know, any time that we need to move a lot of data on our SAN, right? So we have
deployment, for example.
Right. So virtualization hosts that are connected to a common SAN, and I have a VM library down there. I have my VMM library with all of my VHDs and my host. If I need to deploy, if I have a bunch of bits that need to move from point A to point B, I have ODX aware hosts. I have ODX aware storage. This is going to be the perfect case for it. So because, and the key point here is that we have storage in common with ODX, right? I'm not moving data virtually between servers connected to SAN A and servers connected to SAN B over here with some network in between. These are servers that have a storage tier in common, and so I'm changing pointers because I have the opportunity here to simply logically redirect that storage that contains those bits. So.
Okay. Speed up that, basically enhance that deployment, so easy to scale up, easy to spin up new instances, everything like that. So, you know, one thing that we want to encourage our customers to look at as they start to make these new hardware investments, Make sure that your SAN is going to be ODX capable. You're really going to see massive trade-offs in deployment time. Now, I mean, we actually have our own lab that we run a lot of customer-facing events for. Recently got a new EMC SAN, ODX support, and it significantly sped up our deployment time. In fact, we would actually start deploying for events in the past 5 days in advance because we're copying terabytes and terabytes of memory. Now we can do it 1 day in advance. So I mean, we've kind of reduced that deployment time by 80%. And what that means is we can then free up this storage over those 3 additional days to use for other projects. So instead of having to, fill up our SAN for 5 days, gradually preparing more and more VMs, keep it flat until the day before, then load it that day. So great efficiency, really enhanced our flexibility in our lab.
Absolutely, absolutely. And so with the next topic here, if you were to ask Simon if he has any children, he would tell you no. And I would actually argue with that. Simon has one child, and that is failover cluster.
There you go.
So let's talk about virtual fiber channel, the capability to create a cluster amongst virtual machines with direct access to our storage.
So first, I want to kind of define guest clustering and kind of speak about these different layers that we have across our infrastructure. Now, most people know clustering as the physical servers, right? You connect these 2 physical servers together, or up to 64 physical servers. You have an application or a virtual machine that's going to move between those 2 physical servers. Guest clustering takes this to the next level, and what we're actually doing is clustering our virtual machines. Within a virtual machine, we have an application like our SQL database, and so we can actually fail over that SQL database between the different VMs. So think of this as virtualization entirely on the virtualized layer. So not only does this allow us to do patching for our VMs by moving the instance around, but we can detect whether that SQL instance has crashed, automatically restart it, fail it over, move it around. So again, clustering inside the virtual level. Now, speaking to this point of a virtual fiber channel, why is this interesting? Well, this gives us a lot of high-end speed for what's actually running inside our VMs. Kind of looking historically, guest clustering used to support iSCSI, fiber channel over Ethernet, basically those Ethernet-based protocols.
Yeah, so I want to ask you a question with regards to this. It's really almost a religious discussion, to cluster or not to cluster in the virtual world. So when does it make sense for me to cluster within virtual machines, Simon?
For the most part, you're going to want to cluster all of the time. There are a few exceptions where you may want to just make sure that this particular VM is always bound to a particular host. But beyond that, by using clustering, you get a lot more flexibility. You get the ability to restart your virtual machines, to monitor the health of the applications, the VM, the guest operating system, and then you get the mobility advantages of live migration, being able to move that virtual machine around with no downtime. But have you come across other instances, in your kind of day-to-day work where people are not recommending the clustering?
So at the host level, everybody recommends clustering, right? It's at that virtual machine level that I'm really interested. What our use case is for clustering 2 virtual machines that might be running SQL or some other workload. Sometimes we do that, and sometimes we don't. And it really comes down to answering that question. How much downtime or offline is okay for me? And I find that many times with our less critical workloads, if our downtime is really at the end of the day just patch cycles, a few minutes here for a reboot after hours, many times that's okay. This virtual fiber channel capability is a lifesaver in a lot of cases where we want to virtualize a workload, but we know we need direct access to that SAN storage, right?
Right.
But many times we find it's not absolutely necessary, so we simplify a bit, because really just the act of virtualizing a workload on a highly available hypervisor, clustered Hyper-V host, for example, means we've already eliminated much of our risk. We've taken the hardware factor largely out of this, because I can now take that virtual machine and I can live migrate across host failures, right? So I'm resilient in many respects where I wouldn't be on a standalone physical host.
Absolutely. Now, the big advantage of Fibre Channel, though, is the speed that it adds. So again, in our last release, we didn't have these virtualized HBAs for Fibre Channel. 2012, we've now added virtualized HBAs. And so what this means is this guest cluster, this virtualized cluster, it still requires shared storage. Okay, that's important to keep in mind because we still need the application to be able to access its data regardless of which VM that application is running in. But big advantage with these virtualized Fibre Channel HBAs, we can now use our fast, high-end Fibre Channel storage for these applications that are running up in our virtual machines.
Which is great. And what's also really important about this, if we can just take a look at this slide here, is that we don't lose our live migration capability. So
That's correct.
So if I have clustered guests that have that fiber channel capability, I can move those workloads across my host. You know, one of the things I remember Jeff Woolsey, when he introduced this capability to the world, he said, you know, we asked customers, what do you not want us to do? And the overwhelming answer was, don't break live migration.
Got to live migrate all the time.
So that's something that Server 2012 does really, really well. It gives us a lot of what I like to call not even availability sometimes, but just portability with the platform. So let's have a look at shared nothing live migration. So this one really blew my mind the first time I saw it. So Simon, while I'm getting into my demo, maybe just set the stage for what is shared nothing live migration.
Great. So what we do with the live migration, and for our VMware people out here, this would be equivalent to a vMotion. Live migration allows us to move our virtual machines or other virtualized components with no downtime. So traditionally, we just think of live migration of moving a virtual machine from one host to another host, no downtime. But with Windows Server 2012, wanted to make that more flexible and give you the ability to also move the storage on a SAN from one location to a different location, again, without affecting the downtime for that virtual machine. And so what this means is now we can actually move that VHD or VHDX file from one cluster, a SAN, to another cluster or another SAN, or to a standalone host, or between two different standalone hosts. So really enhancing that mobility, not just of the virtual machine, but of its underlying storage as well.
And Simon's making an important distinction here. So I'll actually show you shared nothing live migration here in my demo environment. But Simon's making an important distinction here between availability and portability. In mobility, I can move this virtual machine around. This isn't a high availability mechanism. This is just an ability to move a workload around my environment without the need for shared storage. So let's have a look at Hyper-V Manager here. And I have just an ordinary virtual machine here. I'll go into its settings, and what you'll see is that its storage is in fact local. It's on the D drive here in the virtual machines folder. So I want to go ahead and do a shared nothing live migration to move this workload over to another host. So I'm going to move. You notice here I can actually just move the storage. So storage live migration, and if I have a virtual machine that has multiple disks, I can get very granular with this, moving those disks to many places. Now I'm just going to pick this up and move the lot, and I'll send this over to another Hyper-V host in my environment, another standalone host. These two have nothing in common really. So I'm going to move all this data to a single location, and you'll notice when I hit browse here, I'm moving this over to a server called hyperv.contoso.com. I'm being presented with Hyper-V's storage here. And I can go out here and find the virtual machines folder, which is my standard location. I select that folder, I hit next, I hit finish. Now this will not be a fast process in my dev environment. It's going to go pretty slowly actually because I'm copying across a not high performance network. And what's happening here is that virtual machine is continuing to run in the source. So there's no interruption to the service here. All of the the active data set over here is relatively small. It's memory and a bit of disk that's moving about, but all of that data that's not active is being moved over to the other system as we speak. When it gets to the point, when this process reaches that point that we need to just take that active data set and bring it across, there's going to be a momentary pause. The data is copied, the workload comes up on the target, and once it's guaranteed up and running, that's only, then and only then is it going to be eliminated on the source. So we're never going to have any sort of interruption or loss of a virtual machine here because Windows is doing a very thorough job of ensuring that the workload is up and running on the target before anything happens. So I'm not going to make you watch all of this, but I really just wanted to call out that we have a lot of flexibility here in moving our workloads around our environment.
No, we got a question here. I mentioned that we now have the ability to move from a standalone host to another standalone host, right? So people are asking, why do I still need clustering, right? If we have this mobility, why is clustering still relevant? So key thing to think about with clustering is clustering protects you from unprepared downtime, unplanned downtime. live migration is going to be used during planned downtime or planned maintenance. And the reason why, when we do a live migration or storage live migration, we need both of our hosts to be online and communicating with each other throughout that process. If one of those hosts crashes, we can't copy that in-state memory, so there is no live. We'll just do what we call a failover. So big advantage of clustering, it not only supports this mobility feature, but it protects you against these crashes because we detect the crash, we restart the service, we move it to another host. If you had a VM running on a standalone host, that VM crashed, that host was non-clustered, that VM is going to stay offline until you run some other type of background, do some other alert as part of it. So definitely want to keep clustering as part of this, even though we have these additional migration capabilities.
Yeah, that's a great point. It comes back to the distinction between portability and high availability. So two very different things. What you saw me executing, there was a planned operation.
Both servers were online and running the whole time.
Yeah, exactly. So big difference there. So let's talk about, I'm going to go back to that classes of service, and I want to talk to you about storage classification. So we've talked about the storage capabilities within Server 2012 that we can deliver higher performance, high performance at a lower price point than traditional SAN perhaps. But as we are bringing our storage tier into VMM, into our primary virtualization management interface, we need to take that storage layer and carve that storage up and present it to pools of resources in accordance to performance and cost, right? So it all comes back to efficiency. Just as I'm not going to use my latest and greatest Hyper-V host for test and dev, I'm not going to use Fibre Channel SAN or SSD storage for test and dev workloads. I'm going to move those over into the production realm where they're servicing mission critical, high performance, high scale, high throughput applications. So with VMM 2012, we have full capability to talk to an SMIS provider, a standard interface for enterprise storage. And many of our storage OEMs out there have their own SMIS provider. We can stand that up and through a simple wizard in VMM, connect to that storage system, and then provide visual capability to look at what we have and to classify that storage based on how we would like to leverage in our cloud environment. And I'm really not doing it justice because it's really more than just bringing in SMIS with traditional fiber channel, because there's an SMIS provider Microsoft gives us for iSCSI, so I can bring in my iSCSI storage. In SP1 for System Center 2012, we also see the capability to take the SMB over Hyper-V over SMB situation we were talking about, and to visualize those folders in VMM. So I've got full visibility into my storage. I can take those folders, put them onto my host, and specify those as paths where we can deploy assets. So I'm going to carve up my storage and allocate my storage with all of these capabilities in mind. Largely dividing that up based on performance. So whether you do gold, silver, bronze, or dev, staging, production, or we even break these up in a hybrid of these, where we look at perhaps storage that's classified by country, and then on into those dev, test, prod type classifications at that point. So see, we're still doing the move there. It's not a fast process, so I kept my promise there. It's going to take a while. So while we're doing that, I'm going to get back into the fabric here, into my network storage and compute, and I'm going to look at storage pools and classification. So you'll see here that when I right-click and attempt to create a storage classification or work with my storage, I can add storage devices. So you can see here the SMIS provider, which was what we saw in RTM, which today supports iSCSI as well. You'll notice that SMP provided there. I can add block storage basically. But what I really wanted to show you was this Windows-based file server as a managed storage device. So I create a scale-out file server cluster. I create shares sitting on high-performance storage potentially. The idea here being that I'm going to achieve that high throughput, but in an interface that's going to simplify. Potentially I have storage spaces behind these folders, right? So I have SAN-like capabilities, potentially high performance, and I'm now, really only requiring that my virtualization admins understand file shares, which I think they can all appreciate. So SMB and file sharing in the Microsoft world has been something we've been working with since before I was born. I'm such a young pup. So once I run this wizard and add a file-based, a file-based resource, you see the wizard's going to ask me for the IP or the FQDN. I can specify whether this is a trusted Active Directory domain or not. You notice the run as capability here, so I can supply secure credentials without having to type the passwords. It's here, I set it, I forget it, and VMM always has those credentials securely stored in the SQL database behind the scenes. So when I go down here and look at my file servers, here's what the wizard looks like when I am done. Now you'll notice, the important thing to notice here is out on the right-hand side. There's a column labeled Managed. So I went old school on my cluster and I used a drive for my quorum. So I don't even have to use drives today for quorum, do I?
That's right.
So we could use a share for our quorum, a folder. So I'm going to go in here and look at the properties of one of those folders. You'll notice that I've quite simply just checked the box, File Share Managed by Virtual Machine Manager. That's all there is to it. And I've provisioned 300 gig shares here. And what I can do now, if I just scroll up and look at the server aspect of my cluster, and I want to clarify, we didn't show you how to add a Hyper-V host to VMM. We're going to get to that point where we look at adding the virtualization layer. I think it takes about 3 minutes to read on TechNet how to add a Hyper-V host. It's trivial. Clustering in the modern world in VMM is a drag and drop operation. It's ridiculous.
Yeah, you can literally drag that server into your existing cluster. It will go add it to the cluster, give you options to validate everything.
And and don't tell anybody, but in my own test environment, I find I don't even run the prereqs. I just drag it and I let VMM do the work. And if I'm missing a prereq, it tells me. So in my own dev environment, I just like to leave it to its own devices and see how it does. And it's very, very effective.
Drag and drop clustering.
Yeah, absolutely. So pretty fantastic. Now I want to look at the properties of my Hyper-V cluster here. I have a couple of clustered hosts in my demo environment here, and if I look at the properties here, what you'll see is that I have added these file shares on a file share tab here. So basically I've now told VMM, when you run intelligent placement, remember these file shares are a place where you can deploy virtual machines, a highly available place where you can deploy virtual machines, which again is a set it and forget it type operation. Once I've defined that capability, I'm going to trust intelligent placement to determine where those virtual machines need to be placed, and I'm not going to worry about it anymore. So I'm just going to show you here in this virtual machine that I deployed a few hours ago to prepare for my talk with you. We're just going to go look at some information related to the configuration of this host. And I want you to look at the storage here. So HA file server, VM store 3. So this virtual machine is actually sitting in a folder, in a scale out file cluster, sitting on storage spaces. I've got the full complement of capability in my environment here. And my storage spaces is not sexy in my environment. I took some JBOD and threw them in a server, and they just barely qualify, frankly, to do this. But I could take a lot of disparate SATA storage and turn it into something much higher performance and useful, because I couldn't hook these up to a RAID controller because, frankly, I didn't have one. So now I'm doing it at the software layer. And this brings me to another question, Simon. So we hear in the field a lot, sure, I can create high availability storage in the software. We had that back in NT4. What's the performance of this really going to be like?
So you're asking the performance of just running anything in a cluster?
So if I'm leveraging all of these capabilities together, and I have storage, I have storage spaces in the back end here, and I have good storage back there. What is the overhead of the software really going to do to my throughput here for my storage?
I mean, it's very minimal. When you think architecturally around what virtualization does, we're essentially adding a layer of translation on top of this physical hardware. So I'm an end user sitting above the layer. I say I want storage 1. we speak to our virtualized layer, and it will map storage 1 equals this particular controller, this particular drive, things like that. So anytime you're using virtualization, again, across any different platform, Citrix, VMware, Microsoft, there's going to be some performance here because it still needs to go through this virtualization layer and do this mapping, this translation. Nevertheless, speed and performance are some of these critical requirements that we see from our customers, and those are part of our common engineering criteria, this really long document I referred to in the first module. So bottom line, yes, there will be some performance hit. It's often very minimal, less than a few percent. But if you really want to figure out what our real-world customers are finding, we'd encourage you to go online and Bing search virtualization case studies. And what you're going to find is there's a lot of people out there who are VCPs and MVPs, both cover Microsoft and Hyper-V, third-party companies that do research that are actually doing these head-to-head comparisons, looking at what type of performance hit do you have if you virtualize SQL, virtualize your storage, these different components. So rather than trusting us, we really want to encourage you to see what the real world says, real performance data. So just go do a Bing search and take a look at some of these tests for yourself.
Yeah, and the important point there, so the adjective I was looking for from Simon was minimal. And so if we think about this from an infrastructure perspective, we have Hyper-V hosts running on new hardware. We have SMB3 capable operating systems. We have new network adapters like bandwidth in those adapters. We have receive side scaling capability. We have a scale out file server cluster, and we've sized that hardware appropriately for high throughput workloads. And if we're using storage spaces, we have reasonably high quality storage behind that. There's no reason that I can't use SATA and some of the less expensive storage for the lower end workloads, but I can go buy a JBOD tray of SSDs or SAS storage and get that high performance without the high complexity that I might have with a SAN. So particularly if you're going into a hardware refresh and you want to look at simplifying, this is an opportunity to do that. If we look at the data center, and I hear customers all day long complaining about cost in the data center. Number one cost in the data center, storage. In some organizations, storage is more than half of the cost. So to save money while maintaining that good performance is really a big deal. It's not a trivial matter, and if you can demonstrate some of that, we're going to find that adoption is going to make sense in a lot of organizations.
Excellent.
All right, so let's just jump in and press on. So Hyper-V over SMB3, I think we've covered this pretty well at this point in time. So it comes down to the hardware. So Hyper-V is only it's going to require that we have newer hardware. We need receive side scaling. We need network adapters of like bandwidth. So a lot of times today we're dealing with blades that have 10 gig throughput. A lot of other SMB features we're not going to dig too far into. We talked about multi-channel, which is just there, set it and forget it. We've got SMB encryption. We've got PowerShell management capabilities. We've got transparent failover. So if we lose a host in the process of a file transfer, no impact to that session. Everything is going to continue on just as it was. Let's just press on through some of the bits we've already covered. We can look at our scale-out file server just briefly here.
Yeah, sure. So as you kind of switch over here, scale-out file server, what's kind of the key benefit? So essentially what a scale-out file server does is it allows us to put our client access point, which is whack my share, across multiple different physical servers. And so what this means is, with traditional clustering back in the day, all of the clients would go to a single client access point, a single host, go from that host through that SAN down to the storage. What we wanted to do with the scale-out file server is both provide some basic load balancing or load distribution capabilities, as well as resiliency. So by having this whack my share across these multiple different hosts, we will actually help distribute those incoming client connections across those different hosts. And that in turn distributes that across the different SAN connections. So you're kind of doing some basic load balancing with the traffic. Secondly, as you kind of mentioned, if you lose a connection, one of the clients, the server crashes, that client access point is no longer available, the routing table will go and look at the next available server, redirect the client to the next host that does have that share up. The client will reconnect, and they can continue doing their file copy operations, everything like that. And from the client's perspective, for the most part, this failover is transparent. Even if they're doing a file copy, as long as they're using a file copy mechanism with automatic retry built in, such as Xcopy or Robocopy, there might be a temporary pause during the failover. It goes to that server that's no longer available, goes to the server that is available, and it will kind of continue that operation. I think the only time I see that kind of break is if you're doing one of those, old school copy and paste between the shell, actually doing a full, GUI copy and paste, because that doesn't have that automatic retry logic.
And I won't linger too long on the scale out file server, but just looking at my interface here, I'm just using Failover Cluster Manager to manage this. So we do want to think about the limits of scale, right? I can only add so many file servers in this scale out cluster. I believe it is 8.
Yep.
Right?
Yep.
So I'm looking at the expert here, but so here I have basically a virtual server answering to a single name. So I lose one box, it doesn't matter. I've got an IP out there in DNS. Everybody's resolving to a common point, and we're transparent. So nothing magic here. It's cluster technology that you've been working with for many years now.
Now, there are really actually two kind of cases that we're going to see as use the scale-out file server in our virtualized environment. So one of the ones is, of course, our library server, where we're actually storing our virtual machine files. If you're doing a deployment, you're copying in and out of this library, it's great to make that distributed, highly available, so if you lose a path, you could continue copying. But secondly, we want to think about actually using this as part of our, our SMB, as our back-end storage for our virtual machines as well. So if you think about what we're doing with a cluster, right, we started saying that you just need shared storage, not necessarily a SAN, shared storage, and that can include using SMB. And so what this means is we can actually put our VHDX files or VHD files on a scale-out file server. And so what this means is we have multiple paths that are now accessing our SMB file server from our cluster. So kind of take it a step back, this means we can now almost do 3 different layers of clustering throughout this distribution. We think about our physical servers as a traditional host cluster, right? VMs move between them. We talked about our guest cluster made out of virtual machines, where we have our applications moving between the different VMs. Now we're clustering our actual storage level as well, and we're making access to our VHDs highly available. So you can now actually do this clustering throughout the stack, manage everything using Virtual Machine Manager, and you know what, just to throw a curveball in there, I'm going to add a 4th one. You could go cluster your management hardware as well. Cluster your System Center Components Virtual Machine Manager. So you could get your storage available, your hosts available, your virtual machines available, and even your management software highly available, clustering throughout the stack.
Exactly. So we want to think about availability and performance at every layer,
every angle, eliminating the single point of failure. That's the ultimate goal.
Right. So I want to get to the elephant in the room, or about to be in the room, and that's our networking. So we're going to talk about the physical network for a moment. So when we think about the physical network, I don't think about it a lot of times, other than I need to talk to the networking team and understand what our VLANs look like on the back end, how they expect us to interface on the network. Generally speaking, when we think about what I call our data center networks, or our back-end logical networks, I'm going to have things like a cluster network, a live migration network, etc. And these will often have their own VLANs, and there's no assumption that we're going to be communicating between those networks. But I need to make all of those, I need to have all of those discussions with the networking team first to understand how the physical network is laid out, so I can configure the logical network in Virtual Machine Manager to interface in a way that makes sense. So VLANing doesn't go away, it's minimized, but when we look at the physical layer, we're still going to have VLANs back there for those back-end networks. So I'm going to reference those as I configure my logical network on the front end of this situation. But once I have that discussion and I understand what my interface is from a physical perspective, I can build the logical, and then I'm already a layer abstracted here, and I don't have to worry much about that. I can define this one time. We'll look at a logical switch in Hyper-V. We'll look at a way that we can, through VMM here, define a template, so to speak, that will allow us to make configuration of the logical networking that's going to control our interface with these physical layers here. A very reliable process. and we'll look at NVGRE, which is something we think about from the VPN days as something we're going to leverage in a completely new way in virtual networking. So real quickly, let's talk about host configuration and just talk about our networking configuration options. So Simon, can you speak to non-converged, converged?
Absolutely.
And the difference between the two?
What a pain that used to be, huh? So as we kind of looked at, what was required in a traditional private cloud infrastructure, we made some assumptions. Primarily, you have a cluster there, right? You got the cluster for your virtual machines. But as we kind of looked at what you really need in a cluster, the key design principle for cluster networking is to really try to isolate each network by its particular role. And again, let me emphasize, this was our thinking in the past. We kind of moved a little forward from this. Now, the reason why we wanted to kind of separate each of the roles is to ensure that something happening for one function on one network wasn't impacting the health of another function. Most importantly, being our cluster heartbeat network. This is basically a lightweight ping that goes between one host to another host to make sure that these hosts are talking. The problem that we would see is if you flooded that network with, let's say, live migration traffic, the network's fully saturated, those pings between the different servers might not go through. That might then trigger a false failover and cause one of the nodes to shut down, cause failover operations to happen. We don't want that, right? And so to avoid this, we used to recommend dedicated network for each of your different cluster roles. So you'd have a network for your internal cluster communication, which included this heartbeat traffic, updates to the cluster, CSV communication. We had a public network, and so this was for our clients, our applications, our end users to actually go and connect to our VMs. We wanted to separate that in case there was some type of, let's say, denial of service attack, somebody flooded that network. We don't want that to impact the underlying hardware, the underlying cluster. Now, when you started to add Hyper-V in the mix, we recommended having a network for live migration and a network for our deployment and our management. As you go and push a 10 gigabyte file to a host, hey, that can use up a lot of resources there as well. Now, as we kind of extended it and thought, okay, what about backup? Backup recommends having a dedicated network once again. And then different customers were using Ethernet-based storage protocols like iSCSI, Fibre Channel over Ethernet, SMB. That again talks over yet another NIC. So we got up to 6 NICs as kind of our recommended value if you have a Hyper-V host. And a lot of customers, they only have 4 ports in their Blade servers to actually put in Ethernet cards. So lots of challenges there. But what we've been happy with is kind of the large adoption and growth of 10 gig E. Both, reducing the price of the networking cards, the switches, all of those other, interconnected pieces to just make the solution cheaper. And now we've tested and we've got great success actually using just a pair of 10 gig E networks, and that has enough throughput to cover all of these different roles.
So are you using any special technology there to segregate the traffic in any way or silo in any way?
So we can. We do have the ability to go and actually carve out the different networks if we want. And some people do like to take advantage of that because of quality of service, right? Maybe you want to prioritize the heartbeat traffic as high importance. And maybe the live migration is second most important. So you do actually have the ability to go and actually say, this network should do this should do this should do this. And you can carve up a single network using VLAN tagging as well to really break up a single network into different uses for different virtual machines.
And then what about virtual machine queue? So VMQ at the hardware level gives us some capability then to silo.
It does. So if you're using VMQ, this is basically a component of technology that's actually built into your actual NICs, the actual physical hardware. What this could do is it could do some offload and some different types of processing as well. So you're not actually doing a lot of this additional network translation in the server. You're kind of offloading a lot of this processing to the virtual NICs. So it gives you some more features, faster throughput, better way to kind of really optimize and manage that traffic. So long story short, what do we recommend now? Well, now that we've got enough throughput through these 10 gig E connections, we now have inbox network teaming across all of our different cluster roles. We're finding great success with just a pair of teamed 10 gig E network adapters. Of course, the more the better, additional resiliency, additional availability. But, just using that, great success, fully supported, now recommended.
Awesome. Thanks for that, Simon. So let's move out of the physical now and get to the meat of the discussion here, which is the virtual networking.
So first, why would we want to virtualize a network?
Wow. So
why wouldn't we almost, right?
why wouldn't we is really what it comes to. When we look back at the challenges of traditional networking, we know that VLANs have a limit. VLANs have a scalability limit of 4,096, and our frustration threshold is much less than 4,096 just due to complexity. And it's an inefficiency that we have to go back to our network team every time we're creating onboarding a new workload. We have to go back and talk about more VLANs. So it's a lot of time wasting, frankly. And when we move into the world of a shared cloud fabric here, we have the reality that we have these sort of apartment dwellers, these roommates that need to coexist in a way that we can ensure everybody gets the resources they're promised, that their data is secure and isolated where it needs to be. And virtual networking is going to allow us to address that. It's also going to allow us to walk away from that VLAN nightmare and that's really what it is. It's kind of a nightmare at the end of the day. And now with virtual networking, I'll be able to compartmentalize in a way that previously only would have been achievable through VLANs. And this is using underlying technology of NVGRE, we call it. So similar to technology that's been used in VPN, for a long time.
GRE, generic resource encapsulation, right?
Yeah. So the NV being
network
now
virtualization, generic
GRE.
resource encapsulation. Tongue twister.
Yeah. So merging the logical and the physical. So we've talked about that physical network, and really what the logical network that we're going to configure, the logical networking components we'll configure in VMM are telling VMM how we're going to interface with that physical network. So we're modeling the physical network, so to speak. I'm separating my subnets, my VLANs. I'm going to have a logical network typically for my data center, for my back-end networks like clustering, live migration, storage, host management. I'll likely also have a logical network or a provider network, we call it, a network that provides access to my tenants, to my business units that are sharing this common fabric. The logical switch is really just an enabler that allows us to configure the new extensible virtual switch in Hyper-V in a very consistent way. I like to think of it as a template of sorts, a container, because it allows me to define switch settings so I can apply them consistently across my Hyper-V host. I'm effectively raising the control plane to a multi-server capability now. So I can move workloads across Hyper-V hosts. I can isolate that traffic so multiple tenants can coexist even if they can't directly communicate. So maybe we just take this from the bottom up. So in the beginning, there was the physical network and our virtualization host, connected with their network adapters into that physical network, and then the internet where one or more of our workloads may need to reside. So we begin by defining a logical network, that definition of how our host and our guests are going to interface with our physical network. So I define my logical network, and within here I'll configure what we call network sites, basically defining my VLANs for my back-end networks, and a logical network for my clients as well. And we'll move up the stack into VM networks. Now this is really important. So in VMM 2012 and in Service Pack 1, we're no longer directly connecting our clients to a logical network. We're now doing this through a VM network, and it's this additional layer that's unlocking that capability to virtualize the networking. And what's important for you to notice in this picture here is we have two tenants who may be isolated, who will be isolated in our example, connected to a single logical network. So in the past, we would have a one-to-one relationship between those two. So now I can potentially have, with network virtualization, with this capability to use NVGRE, I can have as many as, correct me if I'm wrong, 16 million virtualized networks.
I can't count that high. I'll trust you.
Yeah. So I think it's 16 million. It's 15.99999 million more than you're going to need, frankly. in this environment. And I don't have to go back to my networking team and ask for VLANs. I can carve this up in a matter of a few minutes because I had the discussion about those back-end networks and the provider network they were going to give me to interface with their physical. So I will create logical switches. So I do need to create these logical switches. Number one, for the consistency this gives me in configuration, because it will allow me to define what we call port profiles. I can define my uplink ports that tell us how we're interfacing from a switch level into the network.
As we're kind of covering all these topics, I see we're kind of talking about a lot of different components here. First question that came in: can I manage all of these using Virtual Machine Manager?
Absolutely, you can.
Absolutely. Yeah. And that's what we really want to encourage our customers to use as well, right? Use this single interface, get that broad scale management.
Yeah, and I wanted to make sure that today, since we were limited on time, that we could show you some working models. And this network virtualization, we wanted to be able to step you through this so you can actually see what the configuration looks like, and we can explain why we've checked the boxes we've checked and how this is all interacting. So you see the sort of fully baked version of network virtualization where we have multi-tenancy with that isolation, where our clients are coexisting but not communicating directly. After we create that logical switch, the next step is we actually have to assign that logical switch to our host. So we'll apply that consistently across these hosts. We'll define our uplink ports. There's a port classification. I like to think of that as a global label. Allows me to put a friendly label on these uplink ports. And finally, some of our workloads are probably going to want access, outside of their little isolated subnet, and that's where a gateway comes into play. So I can basically create and assign a gateway to these tenants so they have a door out to the internet. Simon, so tell us something about gateways. Where are we today? Where are we headed with this gateway role?
Great question. So, essentially you want to think of this gateway as kind of a layer of translation. I'm talking a lot of layers of translation. Kind of a layer of translation from our intranet, our file servers, our other corporate resources, to this private tenant's gateway where they have just this pool of unrestricted IP addresses. Now, if I'm running in this pool of IP addresses, I have my own 1.1.1, whatever. When I want to go out and speak to, let's say, a file server out in the real world that's on my real internet or my real IP addressing system, I basically need to use this gateway as a translation mechanism. So what I do when I go from my private network, my isolated network, to the gateway is actually going to go and add some, encapsulate this IP address request. Now, encapsulation essentially means you're adding tags to it so that whatever resource is reading this IP address, it can see the tag and then send that tag to the correct underlying user, the correct end user. So as we go out through our gateway, let's say we contact our file server, get an IP address, get the information we need. When we send it back through our gateway, that gateway is actually going to have a tag on it to user 5, and that will go then reconnect that particular end user to that particular IP address. Now, the way that Microsoft personally uses this own, infrastructure, our own private networking, is so that we have our own deployment flexibility. Now, in my own office, I have about, 15 servers. I run lots of VMs across them. And I don't really want to be restricted by saying, hey, you only have 20 IP addresses, right? I want to just be able to go deploy VMs, not have to worry about IP address management whatsoever, not be limited by, what I can show in a demo. So essentially, what we do here at Microsoft is each of our own hallways, we basically have our own range of IP addresses. They've set up a gateway for each block of offices so that within a set of, 8 to 12 to 15 offices, we have 256 IP addresses that we can freely use, spin up, spin down. When we want to go outside our office back to the main campus, the main corporate environment, everything gets handled by the gateway, does all of our address translation. So I just don't even need to think about it. And so for customers that have a lot of virtual machines, let's say a lot of dev environments, a lot of test environments, the developers are just spinning up resources, they don't want to think about IP address management, this can be a great solution to just keep them on their own network, give them a huge range of IP addresses, and just simplify the overhead and management for you.
Yeah, so one last concept before we get into the UI here and have a look at virtual networking. We want to talk about addressing. So IP address pools were something introduced in VMM 2012 that give us the capability to statically assign addresses at deployment time. These are pools of addresses. This is not DHCP, so if you're using address pools that include ranges that are in your DHCP deployment, you want to make sure you go back there and put some exclusions in DHCP. These are created through a wizard in the UI. They're going to ask you some very DHCP-like questions in that you'll have to supply a gateway, a DNS server, a Win server if you still use Wins. You don't use Wins, do you? I didn't think so.
No.
I didn't think you did. So before we even get into our demo of configuring virtual networking, I want to rely on my finger and OneNote here to just draw you a picture of what we are about to build in our what we're about to look at in our demo environment. So I have my physical network, which is back here. I have my logical network that we're going to define. It's warm in the studio, you can see. And I'm going to have my Hyper-V host here. So I'll put my Hyper-V host here, and we'll define multiple logical networks. So clustering, storage, live migration, etc. So whatever my logical networks are. So I'll define those. Now what I'm going to define up here in terms of tenants, I have, we'll call this Contoso, the blue customer, and Woodgrove, the red customer. So these could just as easily be finance and HR, you name it. I have multiple virtual machines here. We want these virtual machines to be able to communicate with one another, potentially share address ranges with one another, and effectively allow us to run multiple virtual networks on top of the same single logical network. So what I'm going to show you are two tenants, each with two hosts that are identically addressed. So they have a VM1 and a VM2 and a VM1 and a VM2. And those, the VM1 on each side has the same IP address, VM2 on the other side has the same address. But what you'll see is that tenant 1's host cannot communicate with tenant 2, and tenant 2's host cannot communicate with tenant 1. So we have this isolation that's delivered through network virtualization through this NVGRE capability that only comes when we get to Service Pack 1 with System Center with Windows Server 2012 that has support for all of this baked into the hypervisor and the operating system. So let me jump out to my VMM console here, and I'm going to start with logical network. So again, the logical network is how I'm going to define how my hosts interface with the physical network. And so you'll see here that I have a couple of networks. I have my client virtual network, or provider network. This is providing access to the virtual clients. Now the wizard, when we run this wizard to configure network virtualization, the client network, when we want that isolation, we're going to check the box here to allow new VM networks created on this logical network to use network virtualization. This is the magic box that you need to check to light that feature up. Just wanted to get that out there right away. Now what I've done here is added a network site. So this is how I define my subnets and potentially my VLANs. Now on the client side, I've got VLAN 0, basically no VLAN at this point. I have a single logical subnet. I'm going to have multiple virtual networks though that can leverage that single logical network. Now we want to look at the back end as well. So I'm going to run a wizard here and just talk through how we might configure this in a large enterprise. I have this fully configured so I can show you the end result fully cooked, but I want to just take you through this capability. So I'll call this my data center network. Now the box we need to check back here, typically when we're dealing with data center networks, which are typically going to use VLANs, I'm going to check this right here. Network sites within this logical network are not connected. So I don't mean that they are not connected to the physical network. I mean that the network sites, the subnets and VLANs I defined in here, they won't talk to one another because I don't want my cluster network to talk to my storage network and my storage network to have traffic over in my live migration. I'm going to logically segregate these, right?
That's an important point.
Yeah, so I wanted to call this box out because it's the number one question I get in this wizard is why would I want these to not be connected? Well, you want them to be connected, just not with each other. You know, they're not BFFs at a sleepover. They're function-specific enterprise networks. So I'm going to add my first network site, or we'll call it logical network definition. So you'll notice here I need to assign this to a group of hosts, and you know, this is going to go back to that conversation I have with my network team. They're going to tell me how the physical network is wired so I can define the logical in a way that makes sense. I'm going to add, let's call it VLAN 8. I'll put a subnet in here. And I'll put my net mask, so a familiar format there, and I'm going to call this storage network. And I'm going to hit that button again. I'm going to add another one, and this will be my cluster network. So this will be VLAN 9. This is the cluster. And I'm putting unique addresses here. We're going to get to that IP address pool, so you can already imagine I'm defining these different subnets here. I'm going to have to supply a pool of addresses that we can provision from, right?
Yeah, as you're typing that up, I have a question that just came in. Great point. Is there any way that Microsoft provides some type of way for us to go and test some of these System Center features? Actually, there is. We've just released about 12 or 15 different virtual labs covering all of these different System Center products. So if you go to aka.ms/SC Labs for System Center Labs, it'll actually take you to our TechNet Virtual Lab homepage where you can actually kind of walk through this. You could configure the storage pools, you could configure the network pools, the virtualized IP addresses, and a whole lot more. So great resource for you to get some of this hands-on training experience. Again, that's aka.ms/SC Labs.
Okay, so just to finish off that point around the logical. So I've defined my network sites here. I have my multiple logical networks. They're VLAN, right? So I talked to my my network folks, and they told me what my VLAN configuration looked like. So I have logically configured how my hosts are going to interact with the physical network at this point. And again, they are connected to the network, but not one another. I check that box to make sure they're not connected. Now I'm going to drop out of that wizard, and we're going to look at my actual live network here. So once I've configured my logical network with both my back-end data center networks that we just saw, and then my client network, my provider network we call it because it's providing access, I'm now going to configure my virtual network. So I'm going to move out of the virtual world and into the physical. But first, I'm going to define my IP pool. So I want to put some addresses on these logicals so we can connect to, we can provision host here and have an address pool to pull from. So I'll actually right-click that network, select Create IP Pool, and it gives me a simple wizard here where I can define which network I want to connect to, IP address ranges, gateways, DNS, WINs, etc. So I'll just drill down into the completed configuration here. So you see that this pool is for my client network. I have my network site that I configured in the logical setting, and here's my unique value. I have to give it an IP address range. I want to make sure that I'm watching that range versus DHCP, and then my DHCP-like questions, DNS, WINs, etc. So once I get my IP address pools out of the way, I'm going to move from the physical world into the virtual. So we're going to change gears here. So I've been down in the Fabric workspace of my VMM interface. I'm now going to pop into VMs and services. So what I'm going to do is define one VM network per VLAN essentially, and then one VM network per virtualized network. So I'll have a VM network for each of my clustering and live migration, my data center networks I defined, but then I'm also going to define a virtual network for the tenants that I'm going to have out there. So I want to make sure that I select VM networks on my ribbon up here so I actually see VM networks and not VMs or services or what have you. So you're going to see here that I have some data center networks on the back end. In this particular environment, I have things like production, like my iSCSI that connects me back into my storage, and it's associated to its appropriate logical network. And you see here that I can even restrict visibility into this network. So I have full role-based access control with VMM that's AD integrated, so I can create my user roles that we'll talk about to cordon that off. Now what I want you to focus on here, though, are these two networks right here, Corp1, Corp2, each of which have an IP address pool. So let's drill in and look at the range. So I have 172.16.1, and I have addresses 101 through 120. I'm going to go down and look at number 2, and you're going to notice 172.16.1.101. I've got the same IP address range, right? So these are identical, meaning they could, this would be a massive collision in, any previous release of our pre-network virtualization capable platform here. But now I'm going to have these two virtual networks that are riding atop the same logical network. So when I look at the network here, you see I'm on the same client network and the same MVA client network. So this network virtualization is what allows me to break that one-to-one relationship between the virtual and the logical, so I can have multiple tenants now riding atop the same logical net that's mapped down into the physical. So let's have a look from a virtual machine perspective at how this manifests itself. So I'll just type MBA here, which will filter down to my guests. So we'll see that I have Corp1's VM1 and VM2, and I'll just open these up and connect via the console here. And all I really want to do is ping out from host 1 in my Corp1. So again, Corp1 could be your finance department. These could be departments, not necessarily companies. So I ping out, and then I can use ARP from the command line to figure out what my MAC address is for this host, this guest that I'm pinging. So I pinged 102, and I'll just highlight the MAC address here, so you'll see it ends in 1C-5C. So what I'm doing is looking at the MAC address here to make sure that when I go over to Corp2 and I ping out from VM1 to VM2, that even though I'm pinging the same address, I'm getting a separate virtual machine host there. So I'm going to jump down to Corp2 VM1. I'll connect to the console here again. I'm going to do the very same operation. This will take just a second to connect. I'm going to ping out in the same way. I'm going to use the ARP command to look at the MAC address of the guest that I'm pinging here. So very same process, ping, ARP. What I want you to notice is that on our Corp1 net, the VM2 guest was 1C-C5. And what we're going to find here is it's much different. Let me just turn this on so I can highlight via a little quick edit love there. And when I highlight here, you'll see C7. So I have two VM networks here. This is network virtualization in action now. So I've got tenant 1, tenant 2. Their guests can communicate with one another, but they can't communicate across that boundary. So Corp1 doesn't know that Corp2 is there, and vice versa. So one big happy family in that request. Now we're not done yet, because the other piece we need to look at are our logical switches, right? We had talked about the logical switches, but before we do that, I want to just point out again, these networks, these guests can ping within their, they have connectivity within their own subnet. They don't have connectivity outside of that. That's where that gateway role that Simon described is going to be really important. I'll tell you in a minute how we could potentially work around that in kind of a half-hearted way to eliminate the need for the gateway for the time being. Not my preference, but we'll get there.
No, actually, I just have a question on the gateway here. So we talked about if you're within this gateway running on the private network, you need to go through it to go and speak to corporate resources, right? What about if there's a corporate resource that wants to see what VMs are running, basically what's behind that gateway? How do we have access to that other than, kind of like query and host, figuring out what type of VMs we have?
Okay, so in terms of
do we essentially still need that gateway to get that visibility of what's happening on the other side in our private environment?
Well, no, so we have the visibility right here.
Through VMM.
Right, yeah, VMM is going to give us full visibility on both sides of that gateway. It's really not constraining us from a management perspective. It's putting that box around our tenants, our apartment dwellers in that respect. So let's hit real quickly back in the fabric here, logical switches. So I talked about logical switches as a container or a template that give us an easy way to consistently define the settings for our extensible virtual switch. I can apply this to multiple Hyper-V hosts and ensure that I'm going to have consistent configuration across the board. So you'll see my extensions here. If I load extensions, be those bandwidth, filtering extensions, antivirus or security firewalling type extensions, I have to load those up. I have to install those ahead of time, and then I can check these boxes here and enable those by default. So that's what an extensible virtual switch is. It's extensible through providers that can bring additional functionality. Now you'll notice here that my uplink mode mentions no teaming. We can definitely configure teaming here if we want. So we'll look at our uplink ports, our port profiles in just a moment. And you'll notice here that I have my port profile, which in this case is a high bandwidth port. Now in VMM, these port profiles, there are a bunch of these provided for us by default. I don't have to define these from the ground up. So I have a high bandwidth port classification. That's the simple label that maps to this port profile, my high bandwidth adapter. So we're going to jump down into our native port profiles, which is where we find these by default, and I can configure new profiles if I want to. So I have, for example, an uplink port I configured for my clients. So I wanted to get in here to show you an uplink port because there are a couple of very important configurations you can set here. So for my client network or my provider network, I'm always going to set this load balancing algorithm to Hyper-V port and switch independent. So this is going to load balance traffic across multiple adapters that I may have connected into this logical network. On the other hand, a port profile for my back-end networks, for my data center networks, we might call them. I'll want to configure something potentially very different. I'll do transport ports. When I'm talking about load, basically the load balancing and teaming of my switches, transport ports is what I'll use on the data center side. Now what I said here is going to depend on my switches. If I have intelligent switches, I need to pick static if that's how they're configured. If I have switches that are capable of dynamic teaming, then I'm going to pick LACP, which is an industry standard at this point. So this is my back end, and again, the Hyper-V port is going to be what I use on the provider side. So just kind of lock and load as you go into some of those hands-on labs that Simon described. Those are the settings and the why of those settings. Now, so what we had talked about was that we require a gateway. I don't have a gateway in this environment, so what do I do if I don't?
What are our other options?
Yeah, what are our other options? What's plan B if I need connectivity but I don't have it? So just a quick checkpoint here. We defined our logical networks. Again, this is the translation of the our interface between the virtual and the physical. We defined our VM networks. This is how we interface entirely now from VMM. We're not connecting anything directly to the logicals. We created a logical switch, and the switch had port classification, so this container or template gives us reliable settings I can now apply across all of my Hyper-V hosts. So we light up a virtual switch with exactly the capabilities and the configurations I expect. I have to assign that logical switch to a Hyper-V host. Now that part is also just a quick point and click and apply. Didn't do that here because I don't want to disconnect us from our remote environment. So creating and assigning a gateway, the last step, but also one I said I couldn't do. This is important because it's how we access the internet. Bottom line, what do I do with a gateway? We heard about that. What do I do without a gateway? So what I can do there is use a VM with two NICs. One would be in an isolated network and another one on a VM network that connects into a logical network that has us on the internet. So kind of two legs, a two-legged configuration we call that. And it's kind of a poor man's configuration if you don't have any option here, but it gives me the isolation that I want, but also gives my clients that capability to get out to the internet. So I wondered if we could touch on just one more topic before we we wrap this session, I wanted to talk about bringing the hypervisor under management.
Great topic.
And we've largely ignored this because it's trivial to bring Hyper-V hosts in under management. We run a wizard, fairly easy to do. But I wanted to talk to those of you out there that have other hypervisors as well. So VMM gives me the ability to bring my Hyper-V host in, to drag one on the other and cluster. Supports both domain and workgroup hosts. In fact, the wizard asks all of that. And we can have those Server 2008 hosts in there. So again, if you've got some legacy hardware and Windows around, bring it in. Everybody's welcome in this case. We're going to add our hosts through the UI or through PowerShell, role-based access control to tie those together. But here's what I really wanted to talk to you guys about, and that's bringing VMware hosts under management. Again, when we do this in the VMM interface, which I'm going to show you in just a minute. Trivial wizard-driven steps. I do need to have an account that gives me permissions over there on the vCenter side of the house, because vCenter is our primary interface. But I wanted to point out a few important things that are very different from VMM 2008. The first of those being connecting VMM to vCenter doesn't result in any fundamental change to your data center tree. As I move the VMware hosts around into different folders, into different host groups on the VMM side, I'm not changing my data center tree. I'm not impacting the networking configuration over there, and you will continue to configure your virtual networking on the VMware side over there with the tools that you're familiar with. Even if you don't deploy to vSphere in phase one, this capability, just connecting VMM into your vCenter instance, is going to give me some capabilities we'll talk about this afternoon to take all of that information and to put that into my configuration management database to give me visibility into my physical assets and my virtual assets. And I don't need to do a lot of work to make that happen. I'm going to run a wizard and make that connection, and then what you see today as we move up the stack, we're going to have more visibility, more capability to get that information from the cross-platform hypervisor into our central repository.
So the question that I most often get asked regarding this VMware management is, do I still need vCenter to sit in there? You're going to see that we will add a vCenter, and the answer to that is yes, we do. vCenter is still a dependency that we have, and the reason why is that the individual ESXi hosts, those VMware hosts, they don't have a programmatic interface that's public. And so what that means is Virtual Machine Manager cannot directly talk to those individual hosts. Now it can with Citrix. If you have Xen servers, we can directly talk to the Xen servers without XenCenter. But with VMware, we basically need vCenter to be an intermediary. So VMM talks to vCenter, vCenter talks to those individual hosts.
And I'm going to come back to what's nearly a global paradigm for me with System Center 2012. There is more than one way to do almost anything. So generally the answer is yes, we can do it. It's a question of how. So in VMM, we have to have vCenter, true statement. What if I can't interface with vCenter? Let's just say, from an organizational perspective, folks tell me we're not ready to take that step yet. What's plan B? We'll talk about Orchestrator this afternoon. Orchestrator, I like to think of that as Visio-like drag and drop automation. There is a set of stencils, so to speak, activities for vSphere that Microsoft provides for free. So I can build automation over there that will allow me to deploy using System Center without VMM if this is just off the table. So just real quickly, let's pop in and have a look at how we add a vCenter server to my VMM environment. So I'm going to be back in my VMM admin console and back in the Fabric area of the workspace here. So I'll look at the Fabric workspace, and there is under servers, I have a
All I have is PowerPoint.
Oh, sorry, I'm actually in my my live environment, so
You gotta duplicate over.
duplicate. Okay.
So as you go back and you switch that duplication, one other thing that I'm briefly going to mention is what other types of integration do we have with VMware? So we kind of talked about deployment, meaning that we can actually have the ability to go and push out a virtual machine or a group of services to our actual VMware host. Okay. But we want it to be more flexible than that. And so the way you want to think about it is our day-to-day management activities, deployment activities, you can do through VMM. So for example, deploying, doing load balancing or DRS, distributed resource scheduling across the different hosts. Microsoft has its own solution, dynamic optimization. You can use VMware's, you can use Microsoft's, but kind of these just standard operational things we can certainly handle here.
Okay, and so now back here in our VMM console, as I have proven once again, Pete is not smarter than Windows. I'm in my Fabric area of the workspace. I've highlighted vCenter servers. I click Add VMware vCenter Server. Going to provide the name of my vCenter box out there. You'll notice Run As Accounts, which means the VMware admins can come over to my desk. They can plug the credentials in for me. I don't care what they are, frankly. And I'm communicating with my host in secure mode. Notice all of the instruction here. VMM does a great job of giving me information to tell me what I need to do to make this configuration happen. So when I hit OK and finish that wizard, here you see my VMM host is now accessible in my environment. And you'll notice that my VMware cluster is now visible in my VMM console. I can deploy to VMware now exactly as I could with Hyper-V. So I've brought these hosts under management, and even though I won't be configuring 100% of my VMware config over here, I'm sure going to be deploying to it. So that's as easy as it is, folks. I really don't have anything more to show you there. It's that simple.
Very nice. Well, as we wrap this up, I do have a few network virtualization questions, though. Just want to kind of hit off, make sure that we wrap up clearly. So first of all, can we use third-party networking products as part of this VMM configuration? For example, firewall products, network forwarding, things like that.
Yeah, so on the VMware side or the Hyper-V side?
On the Hyper-V side, managing through Virtual Machine Manager.
Yeah. So on the Hyper-V side through the Virtual Machine Manager, absolutely. That is the extensible and extensible virtual switch. I can load those providers, install those ahead of time, and when I configure my logical switch, those providers are going to be accessible to me in the UI. So I can light up those additional features if it's firewalling, if it's bandwidth or
load
traffic
balancing.
shaping, load balancing, what have you.
Absolutely. Now, the next question is, where exactly does the DMZ fit in? So if I have servers on kind of my perimeter network, if they're isolated, do I have any special networking considerations or best practices for being able to interact with those servers?
So it depends on the level of isolation we're looking at there. So we do have the concept of a private VLAN in VMM 2012 and Windows Server 2012, and that was just another checkbox, as I can check the private VLAN. The difference to you, fundamentally speaking, is with network virtualization, I have essentially a collection of VMs for a tenant that are speaking. When I go to private VLAN, I can take a web farm, and those web farms can connect to one place. They can connect to the promiscuous interface of that PVLAN, which means web servers going straight to a load balancer out to the internet, not potentially one web server being compromised and then being used as the point to begin to target others. So I can achieve greater levels of isolation over there. So I could potentially have that public leg of that web server straight out to the internet if I need to maybe give it another leg for specific types of traffic over into a virtual network with my SQL servers, and maybe I only allow certain types of traffic out that network interface to further protect myself using those switch extensions to harden the network. It definitely has a place, and it comes back to having that discussion with your network team to make sure we draw the picture of how the physical and the logical and the virtual are going to stack up to give us the level of isolation that we need, within the various confines, within the various segments of our network.
Great. Now, how about quality of service or QoS? Can we use that on virtualized networks as well?
So that's an operating system feature in Windows, right? So we've got native capability to turn that on. Certainly there are some traffic shaping options out there that we can look at, for switch extensions as we go down the road, and we see more partners coming in with features for that extensible virtual switch.
The extensible switch, great. And final question we have, when we showed IP address pools, the question is, do we have any integration with DHCP scopes? So we could see, hey, here's all of our free DHCP IP addresses. Can we go and plug those in?
Okay, so the by the book answer would be, we can use IPAM, IP Address Management, in Windows Server 2012 to manage addresses across DHCP, and it'll do some discovery throughout our network. IP pools and IPAM do not have tight integration today. I can basically run a PowerShell script and get my IP address pools out into a file, and I can bring that into IPAM. We're not going to see that tight integration between IPAM and IP pools until we get to R2.
Great.
And at TechEd North America, we saw some announcements around the next step in that respect. When we actually talk about monitoring our private cloud on day 2, IP pools is a topic that I'm going to bring up specifically because capacity in those pools is going to be absolutely critical as we're provisioning more and more guests in our virtual environments.
Excellent. Well, let's summarize it. So, I mean, you know, across the course of this module, we really focused on the storage, the networking, bringing, you know, kind of all these different hypervisors under management. So hopefully, you know, that kind of covers the basics. We've got our Fabric built, we've got it optimized. Any final takeaways or best practices?
You know, again, just as complex as it needs to be, but as simple as possible. So you understand a fair bit now, I think, about where these features factor in, what sort of use cases would make sense. And so really go off and define those requirements ahead of time, so when we get to the point that we need to build this fabric, when we're designing our solution, we know the answers to those questions, so we know which Windows Server 2012 capabilities we're going to light up in our fabric.
Excellent. Well, thank you once again. Very interesting. A lot of great resources and demos here. And when we come back after the break, we're going to be focusing on preparing for self-service. So, you know, one of these big cloud capabilities is self-service concept, empowering our end users, freeing up time for our IT department. We're going to really focus on some of the design and planning considerations around that.
My favorite topic, have a nice meal and brace yourselves. It's going to be interesting when we come back.
We'll be back at the top of the hour. Thank you.